For Nainoa, Corvus is a bucket. Now, as a bucket, that's the bottom of the bucket, the sides of the bucket, and the top of the bucket. And when you dump the water out of the bucket, it goes right straight through the Southern Cross. Now, I want you to see the cross, so let me erase everything so you can actually see it. And right about 9:30 tonight, it's 1, 2, 3, 4, 5 stars, and it's pointing straight south at 9:30 tonight. Next to it is Alpha and Beta Centauri, and those two point to the top of the cross. But I need my line back because not only is the Southern Cross telling you time, it's rising at 7:30, it's upright by 9:30, and what time is it setting? 11:30. But it's also a measuring stick. So from the top star to the bottom star is 6 degrees. Now, as a measuring stick, if you're trying to find Hawaii, and you see the Southern Cross at 9:30 tonight, and you see this measurement, 6 degrees, become equal to this measurement from here to the horizon, 6 degrees and 6 degrees, that tells you you're looking at Hawaii. But there's another star that tells you that, and it's the North Star. So way back here, this is where I have to apologize for our machine, because our star machine should have that star right here at the end of this line. And that's where that North Star is supposed to be. But about a month ago, our star machine made a horrendous noise when it started up, and that's never good. And it kicked itself 1 degree off. So we have a phone call into Jason, who's living in Florida, and we're begging Jason, please come out to Hawaii, take this machine apart and put it back together again and kick it back 1 more degree, because we can't touch it. But Jason can. So please, Jason, get here, because we need that machine back. But see, that's supposed to be right there at 21 degrees. And the thing is, from the North Star to the horizon is your latitude. So the measurement from the North Star is 21 degrees from here to here, and we are 21 degrees above the equator, and that's our latitude. And it's approximately 1 shaka sign. You just have to go out in the real world and check your shaka sign. So if you went to the windward side or the North Shore and held your hand out at arm's length with a straight elbow, and you put your pinky right on the horizon, stretching your thumb as high as you could, you might see the North Star right at the tip of your thumb. So my handspan doesn't work. I get to about here. So what that tells me is that my handspan doesn't measure 21 degrees. My handspan is probably closer to 18 degrees. But you'd have to go out in the real world and see if you can make that stretch. But let's just pretend like it works. Everybody hold out your hand at arm's length, close one eye, put your pinky on the horizon, stretch your thumb as high as you can for me, way at the back of the room here. I get to 40. But my hand span is probably closer to 18. But now do me a favor, flip your hand over, put your thumb down, put your pinky in there, now I'm at 44. Okay, that matters. As a navigator, you'd calibrate your hand, and you'd want to be consistent. Same hand, same eyeball, same tension in your arm. But you'd also calibrate one pinky, 3 fingers, a fist, and if you know what hook'em horns is, those are all measurements. You just have to figure out what they mean to your particular eyeball and hand. But now let's go back to the film for a second, and I want to show you that time lapse that was taken from the North Shore. So let me erase everything and take a look at this time lapse that is from the North Shore. So we're on Mokuleia Beach on the North Shore. Over here are the lights from Haleiwa side and lights from Camp Erdman, end of the road, North Shore. And let me start it and stop it and get you oriented. All right, so we're looking for the Big Dipper. And once you find the Big Dipper, it's these two stars that point you to the North Star, Polaris. There's the Little Dipper. And now let's watch as that 10 seconds goes by. And that's unique. No other star does that. It's stuck. So the first thing that tells you is you're definitely looking north, because that's right over the North Pole, and it doesn't move, and it acts like a pin stuck in the Little Dipper's tail. But the second thing it tells you is your latitude, because if you measure from the North Star to the horizon, that measurement is 21 degrees. And my hand span, I get to about here. So you'd have to check your hand span and see if you can make that stretch. But there's more. Instead of seeing this as a dipper, I'd like to have you think of it as an arrow. Can you picture this as an hour hand? How long does it take for the Earth to spin all the way around once? 24 hours. So if this is a 24-hour clock, how many hours have gone by if it goes from this position to this position? 12. And to here? 6. And to here? 3. So how long was Daniel sitting on that beach taking this film?
Daniel,
Not you.
you want to be?
Oh God, no.
100 years ago. 100 years ago.
About 3 hours.
3 hours.
But there's more. You can tell the exact day that Dan was sitting on that beach because the
Thank you.
planets and the moon move against the background of stars. So if you took a computer back to 2013, which is 12 years ago now, the planet Jupiter was sitting right next to the V-shaped face of Taurus the bull and the Pleiades, the seven sisters, Makali'i, the little eyes here in Hawaii, and in Japan they're called Subaru. And if you took that computer back to 2013 and put Jupiter in this exact position, that's probably within a month of when Dan was sitting there. But if you knew what phase of the moon it was, and it was probably a new moon, that would be the exact day that Dan was sitting on that beach for 3 hours. That's a lot of information that you can get because you understand how the sky works. But now get in a boat. Just a year and 4 months ago, Hokulea was in San Diego, and the latitude in San Diego is 33. Now our latitude is 21. So from here to the horizon is 21. Half of that distance is 10-ish. And if you add 10 to 21, you get 31. Add 1 or 2 more degrees for kicks. And that's where the North Star is in San Diego. So the whole sky has shifted this much. So the navigators learned the rising and setting position of over 200 stars and how they shift as you go north and south. It takes years, and you can do this all day long on a computer, but man, it's different when your feet hit the deck. Because when you're on that boat, you get currents underneath your feet. You get the wind in your face. And of course you get clouds. So if you actually see a star, I hope you know what star it is. And if it's a planet and you think it's a star, well, that could really mess you up. All right, but now we're going to take you on a virtual trip to Tahiti and back, and we're going to be using the computer for this, so let's use the computer sky. And here we are in the Bishop Museum, and if you look over your left shoulder, that is the Ko'olau mountain range, and that pile of buildings on the hill above us, this is Kamehameha Schools. So first thing we're going to do is we're going to hover over the Bishop Museum, face south, and we're going to get rid of the atmosphere so we can see the Southern Cross. So there's the Southern Cross, and it's not quite straight up and down, but now you can see that this measurement equals this measurement. All right, this next move is fast. In 30 seconds, we're going to sail to Tahiti. So we're sailing to 17 degrees south latitude and heading west right into Tahiti. That normally takes 30 days. So now we're gonna head south and the Southern Cross is gonna get higher in the sky. The North Star is getting lower, and when we lose the North Star, that's us crossing the equator. But when you get closer to Tahiti at about 15 degrees south latitude, you run into a bunch of islands because you're heading for the Tuamotu Islands. Now at the Tuamotu Islands, there's an island at 17 degrees south latitude. From there, you say hi to all your friends. They probably feed you real well. And from there you know that if you head straight west and you go for a day and a half, you're gonna run right into Tahiti. And there's tall mountains on Tahiti, which is good, because it makes it a big target. So there's Moorea, there's Papeete, there's the tall mountains on Tahiti. But now look how high in the sky the cross is. There's the pointer stars, Alpha and Beta Centauri, pointing to the top of the cross. But since you know this points the way south and this is 6 degrees, you can use the Southern Cross and you can calculate and you can figure out that this is the South Pole. And then you find something disturbing. There is no stationary star at the South Pole. But from that point to the horizon is 17 degrees, your southern latitude in Tahiti. Now there's about 5 or 6 ways of finding the South Pole. Let me show you a second way. This is the Large Magellanic Cloud and the star Atria, and it's about halfway in between. There's also a dumb way to find the South Pole. Would you like to see the dumb way?
Mm-hmm.
So I look at Alpha and Beta, cross over to the top of the cross, come down the cross, come back up to Alpha, back over, back down the cross, back up, back over. And are you starting to see a slice of pizza? Does everybody see pizza? So the tippy point of your pizza slice is the South Pole. It's kind of dumb, but it kind of works. But now we're going to sail north, and we're going to sail to the equator. So what star am I looking for? And here's your hint. And what star is that? Polaris, the North Star, Hokupa'a, and there's the Little Dipper. But the hint was important. The hint was the Big Dipper. Now, if you see the Big Dipper, you know that these two stars point right to the North Star, so you know exactly where to look. But the other hint, that's a measurement. It's 5.5 degrees. This is a measurement. That's a measurement. This is a measurement. And of course, that's a measurement. Once you've calibrated your hand, you have tools. And once you see the Big Dipper, you can use that calibration and your tools, and you can make calculations, and you can figure out when that star is going to show up. So these are all tools that are sitting up here waiting for you to figure out what they mean to your particular eyeball and hand. But now we're going to sail to 10 degrees north, and there's no reason to sail to 10 degrees north. There's nothing there. We just wanted to get you partway home, but there's probably something